we go to virtualbox.org, where VirtualBox is located, to download the package for Windows. And we go to the downloads. We're interested in a package for Windows since we're running Microsoft Windows operating system. I don't want to download this package because I already have it on my system. So we just double tap. And go on with the installation. So you just follow the prompts. It's relatively simple to install. It's self-explanatory. Because we already have VirtualBox installed on the system, it's prompting us to repair or remove. And we don't want to use any of these options, so we just quit the installation altogether. So now that we have VirtualBox installed on the system, let's begin deploying our guest operating system. So we're setting up our Oracle Linux 9 virtual machine, and in subsequent videos, perhaps we'll consider deploying WordPress on this guest operating system we're going to set up in this video. So we go to machine, new, and we give it a name. We can call it Rocky 9. And here we can specify where we want the operating system file, the guest operating system file, including a disk, to reside. So we want to go with the default, and we can select the disk image. That is the installation media we're going to use for setting up Rocky Linux or Rocky 9. When you select this, you'll have these fields auto-populated with details, or auto-filled with details, because from the disk image or the installation media, VirtualBox will understand that you're running a Red Hat based distro, Oracle Linux 9, and it will populate these fields using the details that it can obtain from your ISO image. The operating system type will be Linux, and Windows, and this field will be the version of Linux or the distro of Linux. Okay, for the sake of clarity, let's just try this and see. Now, we select this. You see, it auto-populated these fields with details. But I do not want to go with this option, because when you set up this virtual machine using these options, Red Hat 64-bit Linux, you don't have smooth mouse integration during installation, where you can easily move your mouse around and select the parameters you want to modify and easily modify them. So what I'm going to do is cancel this installation and do this all over again, so I can use a different option to set up Oracle Linux 9 or a Red Hat operating system or a Red Hat based operating system. So we specify Rocky 9, and here we're going to leave these fields as defaults. We're not changing the location for the disk, for the VirtualBox disk. We're not specifying the ISO we're going to use. We'll do that during installation. So here, the operating system type, we select Linux, and we'll go for Ubuntu 64 bits. And with this option, we're going to have smooth mouse integration during installation, or when we will be taking advantage of the installation GUI environment to define some of the parameters, or perhaps specify the attributes of this operating system. So we move on. And here is where you allocate memory and CPU to your operating system. So you can allocate memory and CPU based on what this guest operating system is designed to do and how much resources is needed to for it to run efficiently. Currently, we have a 2 gig memory set up for this guest operating system, and we'll go with the default. For the CPU, we've got 4 CPUs on this machine. 1 CPU is allocated to it, and that's fine too. We're running Oracle Linux 9 minimal install, This is basically a server environment where you don't have too many packages running and you don't have GUI, so we're not going to use much resources. And for EFI support for special operating systems, you want to have this option enabled. Then we'll move on. And this is where we allocate storage to our operating system. By default, 25 gig is allocated to this guest operating system. For a minimal install like this, it usually takes about 2 to 3 gig or even less. So we can decide to scale down or scale up in the event that this operating system will go on to host many packages, files, and applications. So we won't be doing much, but we can still go on with the 25 gig since this isn't pre-allocated. The 25 gig isn't pre-allocated, and what it means basically is that the theme provisioning option is going to be used. The theme provisioning option allows for dynamic disk allocation. Dynamic disk allocation means that only what the operating system needs it's going to use from the host, from our storage. So it's not going to take more than what it requires to effectively run and support the applications that will be hosted on it. So we use an existing drive. Suppose you have one that you want to select. So we're just going to go with these default options. So now we're done with the setup, the basic setup of our guest operating systems. One thing we want to do quickly before we fire up the machine is to come to the network and decide whether we want to use the network address translation, which sets up a switch. And this switch will translate the address from our host machine so that we can have a network on which the virtual operating systems or virtual machines will exist. And if we want to place the virtual machine on the same network as our host operating system, what we have to do is select the bridge adapter interface. This will allow you to bridge the wireless network interface, and you have the drop-down menu to select which of the interfaces you want to use. If you're connected to your network using this interface, the Ethernet network connection, then you want to use this option. So what it will do basically is to take this and bridge it to the VirtualBox interface. So the VirtualBox interface can afford the capability, or the VirtualBox operating system can afford that capability of existing on your network as if it's a physical node on your network. So what you'll have to do is to give it a different IP address, an IP address that's different from that of the host machine, so that you don't have a conflict or IP conflict. So you can even allocate multiple network interfaces to one guest operating system. You can come to adapter 2, enable it, and decide how you want this to be attached to your guest system. So for now, we don't need this. We can go with the one we currently have. And for some of these options, we'll be looking at them in subsequent videos. For now, we just want to be able to set up Linux on VirtualBox. So now that we're done with these parameters, let's fire up the machine. This will take a little bit longer than we would usually get when we're running this on a bare metal or we're running this on a physical machine. So it's prompting us to select our installation media, since we didn't do that because we wanted to be able to select Ubuntu for installation, so we can have mouse integration or seamless mouse integration during installation. So try mount and reboot. So we want to install. Patience is a virtue. So you just have to exercise a little patience and wait for the GUI installation environment to initialize. And the GUI installation environment is brought to us by Anaconda. And Anaconda sets up a file that we will see upon the installation of this guest operating system, it provides a template for perhaps prototyping this operating system into more operating systems, and this can come pretty handy when you want to get things done pretty fast and pretty quick with deploying tens or hundreds of machines. You can host it in a publicly accessible repository or file system using HTTP protocol, and use Pixie plus Kickstart to perform some kind of automated installation where when you fire up machines in your node, provided they have this Pixie boot capability, they will find the Pixie installation setup on the network and perhaps take advantage of Anaconda and the Kickstart setup you've done for automated installation to run the machines without you having to interact with the installation process. So now that this has come up, we continue. This smooth math integration that we have, it lacks in the Red Hat selection option. So this is pretty important if you want to be able to perhaps modify these parameters with ease. So we want to specify the root password for this machine, the root account that will be set up on this machine, the admin account, specify its password. Please don't use simple password. Do as I say, don't do as I do. Now, the installation destination. We can go with the default disk allocation, or perhaps we can modify this and perhaps define how we want our file system to be set up on the machine or on this machine. We can go with custom setup, and this is basically where you can call custom installation, or which allows you to define the spread out of partitions on your disk. So the first, we've got 25 gig space available. We can decide that we want to allocate the first or we want to set up the file system to be EFI. This EFI file system should be 100 megabyte. Then the next file system we want to set up is boot. And since our kernel will be residing on the boot, and if we do some upgrades to our system, it will add additional kernels. We want to make this file system slightly big enough to accommodate multiple kernels. So we allocate 500 megabytes to our boot file system, and this. So we move on to specify the next file system, which is important. This is swap. We can add swap in so that we have a virtual memory, which is pretty similar to the Windows page file. And by default, when you select the default installation option, this will be set up to be twice the size of your random access memory. That's your memory. So we can specify the swap, and swap is optional. And I think since we aren't going to do much with this virtual machine, we should perhaps let go of the swap and give the rest of the storage space to our root file system. So the next and the last file system we're setting up, which is also important, like the ones we've set up already, is the root file system, which is indicated by /. And we can initialize, or we can leave this blank and hit enter, and this will use the entire or the rest of the storage space that is left. So this is it. You see, we've allocated 24.41 gig or 24.4 gig to the root file system, and we've allocated 100 megabytes to the boot file system, to the boot EFI file system, which is also a required file system. And here we have the boot file system, also required. And for the root file system, it's using LVM, and for the EFI, it's using standard partition style, and this is also using standard partition style. This is because the system will come up before you have access to LVM, and an event, and this can cause some, serious bottleneck when LVM is not loading, and some of the packages residing here needs to load to bring your system up. So it means this isn't going to be available if it's running LVM, and during boot, LVM may not be available at the point that you need the files, at the point that you need the applications and packages in this file system. So that's why it's always important that this uses the standard partition, and the same goes with the EFI. It's using the standard partition. It's not using the LVM. For the root file system, we're using the logical volume. In subsequent videos, we'll go into details about the standard partitions and the LVMs and the importance of having your file system set up using LVM. So now we're done with the allocation of with setting up partitions on our disk storage. So we move on with the installation. And it gives you details vis-a-vis the file system that will be set up on our disk. And if you're satisfied with what you've done so far and you think you're good to go with the installation, you accept the changes. So now we're done. We can move on with the installation. So we begin the installation. All we have to do at this point is just wait things out, because we've specified all the necessary parameters, and all the settings that we've done during this installation setup will be used to populate the Anaconda file that will be generated after the installation. And this Anaconda file can be used as a template to deploy more operating systems with Kickstart and Pixie, which provides automated installation. That's a hands-free installation of multiple nodes, especially in an environment where you have to deploy tens or even hundreds of operating systems. As far as the systems support Pixie boots, then you can have things relatively simple. So one thing we can do during installation, instead of just waiting this thing out and just watching the bar giving us the installation, providing us the installation progress, is to use the Linux virtual consoles. As a multi-user environment, Linux comes with multiple virtual consoles, and you can connect to your system using these virtual consoles. You have 1 to 7 virtual consoles, and you can access these consoles using F1 through to F7. So if we do F1, I think if we do Ctrl-Alt-T F1, so this is the debug, the debug interface or the debug console. Here you can see logs vis-a-vis the installation of the operating system. And what do we have? If we do Alt F2, what do we have on this one? This provides us with the prompt, And now that we have the prompt, we can see what's going under the hood of the installation, like the setup of our file system. We do df-h, which should be available now. And df-h is giving us, the file system, and it's currently mounted. The OS is currently mounted on MNT sysroot. And MNT sysroot is used during installation to it provides a temporary mount file system during installation. And when the installation is done and you bring your system up, so the file systems will be different. But what is used during installation to set up your installation to deploy your operating system is the MNT sysroot. And I think we used to have a sys image or something like that, but this is what we have on the second console, or on the second virtual console 2. So what do we have on virtual console 3, which is accessed using Ctrl-Alt-F3? So we have the root file, we have the file system, or perhaps we have the command line. And on 4, we have the logs. We can see what's going under the hood, debug information. And this is brought to us by dmessage. These are kernel related logs. So on Virtual Console 5, we also have our command line, and 6 is the one to which the installation, the GUI installation is attached. And sometimes you can just watch the log, or perhaps take advantage of the command line to check things and see what's happening under the hood of installation. So in the event that something goes wrong, or perhaps one of the modules aren't properly loaded, you can tell from the debug interface. I think it's located on F5. No, should be F4. Yeah, that's Virtual Console 4. And in case your operating system is not running as it should run, or the installation isn't running as it should run, you can tell from here, and you can decide to quit the installation and maybe change things, do a little tweak, and see if that fixes whatever problem you can tell from this interface. Will probably prevent your operating system from working fine when it is fully set up, or perhaps which will interrupt the setup of your operating system. So all we have to do now is return to Virtual Console 6, and we just wait things out. Oh, skadoosh. The installation is done. We can reboot and boot into our guest operating system. So we'll log in using root and provide a password. So we're done. We're logged into our Rocky Linux guest machine. We can do finger. Oh, finger command is not installed. This is because for the minimal install, many utilities that will be available in the full install or in the full package will not be available. This is basically for servers, and to run some of these packages, you also have some of these utilities and tools available. You have to install them. What you can do is do yum what provides finger. Because we're running yum for the first time, it has to update the repositories. So we just weigh these out. I don't know, for some reason I'm having connectivity issue here and I'm not able to update our packages online. So we just quit. Ctrl C, we quit, and so what we'll do is IP ADDR IP address, and as you can see we've got 192.168.0.144, and we can use NMTUI to set up the network interface to use manual IP addressing. So we change it from automatic to manual and specify the IP. We add an IP address. We can say 192.168.0.125. Make sure this IP address is not allocated to any of the other devices on your network, so that you don't have IP conflict. Now we've specified the IP address, we'll move on to specify the gateway, which is 192 or located at 192.168.0.1. And for the DNS, we can decide to use the global DNS 888, or we can have two DNS, 192.168.0.1, and we add another DNS which is 8.8.8.8. This is the global DNS. And what more have we? So that's all we need to do basically to set up the manual IP, or to define manual IP for our network interface. So that's it, and thanks for watching. If you like the video, please like, and don't forget to subscribe to this channel. See you in the next video.